Okay. Oh, yep. In fact, I just got a little thing that's telling me as much. So, yeah, good job. And forgive me if I'm ill prepared for this, but there are instructions on how to make you don't have to actually send the recording. I think you you give them a link. You make it accessible to ESRA. So, okay,
Understood.
fantastic. So, hi everyone. I'm Bill Dieselin. I'm Director of Environmental Health and Safety at Iowa State University, but I'm also the advisor to cyclone rocketry and I guess this will be my sixth year at IREC, so have I guess a little bit of experience. Anyhow, I'm L3. I've launched a lot of big rockets, had a lot of fun doing that so far, and so just so you know that what we're doing today, you're not being judged. Okay, you're not earning points or losing points. All we're doing is going through your rocket to make sure that you have something that can be safely launched and recovered. That's kind of all we're doing. I think in the past, what happened is we had people showing up to the contest and they had, tubes, or that, and I don't, you don't have to have a pretty rocket, but you have to have pointy end on one side and a place to hook the motor up in the other side and stuff like that. So, so I think kind of really what we're trying to accomplish today is that you have a rocket, and I'm seeing one behind you, so that you have one, and that it is in a it's set up so that it's ready to go. But there will also be a final safety review at the convention center in Midland in June. So just know that. So I'll shut up now. If you want to go tail to tip or tip to tail, it's up to you. But just walk me through your rocket, and I'll ask questions as we go.
We will first go with the tail of the rocket, meaning the fins.
Sure.
All right.
So tell me about this, like how they're attached and so on.
So for attachment, we first epoxied the edge of the fins to the body tube. Since we do have a min-diameter design, we don't have room for an inner tube.
Yep.
So to compensate for that, we did epoxy fillets, and then we did 3 layers of carbon fiber mesh over the fins, tip-to-tip layup.
Okay, great. Just to give you when you get to the contest and a person who's evaluating your rocket can actually touch it, they will probably take 2 of the fins in each of their hands and they'll push them towards each other. I mean, they're not going to use like every bit of strength they have to push that, but they're going to look for movement. So I don't know if you want to demonstrate that or if you believe that they're in, yeah. So yeah. So okay, yeah. Okay. Yep. Yeah. Okay. So I just I actually have had on occasion rockets that I've actually broken a fin by just and I'm like, look, I wasn't, if it didn't survive that, it was not going to survive the launch. So okay, fantastic. Can we swing around, or maybe we're getting ahead of it. I was going to say that usually after I look at the fins, I look at how you're retaining your motor, but.
So we're retaining the motor using a motor bulkhead. I would like to see that. That is right here.
Yep.
This will go. Do I still have you?
Yes.
Oh, he's frozen.
Oh.
Hey, Bill. Bill, can you hear me?
Yeah.
Oh, sorry. Anyway, so this will, once everything is done, be slotted inside, and all thread will be ran into the actual motor itself, or sorry, the motor thread itself. We're using the 05500X.
Yep.
And the way this motor bulkhead is also being retained is through 4 quarter 20 screws. being put in around 57 inches from the aft end of the rocket.
Sure.
We haven't done that yet so far because we're still standing inside the actual inner tube of the rocket.
Yep.
Can you please give me the motor casing real quick? We have this right quick that shows we've made some progress in that. But
Yeah, I see it. Yeah, right. Yep.
It's double that size.
Okay.
Anyways, so that is how we're retaining the motor inside.
Okay. Have you, I don't know, maybe dry fitted because the 05500, that's a DMS, right? I mean, so that's like a big over thick phenolic, I guess you'd say. Have you checked how checked that for fitment?
Yeah, we have. Sorry, that's what I was saying.
Put the motor in as we continue to sand, so we can see that we used to not be able to get the motor in at all. Now we're about halfway on that motor. So we just need to keep sanding until we get her all the way through.
Okay, well, it's better you guys doing that than me. It's that. Yeah. So
yeah.
Okay.
The point of me showing that, sorry, was just to show how much progress we made along that. But yeah, we just slotted it inside.
Okay. All right. So you're sliding it up to some all thread, and then you're spinning it on to the all thread. Okay.
Yeah, give Kyle the camera here. Yeah. Lead. It's all within his system, so he's actually going to talk to that because he's been the main designer behind this whole.
That's okay. So with what Larry showed you, like he was talking about the all thread.
Yep.
Basically, the inside of the rocket will be built and will slide the entire thing together. This accounts for the payload all thread being threaded into the bulkhead.
Yep.
And then being threaded into the motor. There's also a U-bolt that will go onto the payload that connects to the recovery system. That will be assembled before everything gets slid into the rocket.
Okay, let me repeat that back just to make sure that I'm understanding it. Then the all thread that connects the forward closure of your motor to that's going to be assembled external of the rocket. Then you slide the whole thing in, and then you'll run those screws through to attach. Okay, all right, that's great because I'm imagining then you could have a nut on there maybe and back turn it against it, so that it doesn't spin out, or you know what I'm saying, because that would be my concern is, your rocket is spinning on the way up or something like that. Conceivably it could spin out, and if it did, then your motor, it would not be the first time at this competition that a motor departed its rocket, so but is there room for that? I mean, does that all thread, does the forward closure spin all the way up against that bulkhead, or is there a little bit of room in there?
It will go all the way up to the motor. How everything is lined up, the all thread goes about 3/4 of an inch into the bulkhead, into the motor. So we do have a lot of engagement there. I don't believe there is room for a nut of sorts, but we can make room for that. Yes.
Okay. All right. Well, I just thought it would be an extra. I'm not trying to add a layer of complexity on that bulkhead. It is because you're just threading the all thread into that bulkhead, or is it just going through and it's bolted on the other side, or a nut on it?
So on this side here, let's pretend this is where the motor is, right?
Yep.
On this side here is the payload. The all threaded rod is welded to the payload.
Oh, okay. All right. So does
that make sense?
Yeah. Yep.
Okay.
Because that'll prevent both. It's not going to pull through, but it's also not going to turn.
Yes.
So, okay. All right. Now I feel you. I got it. So, okay. Keep going. Keep going north.
All right. So, as he was just saying, the payload connects to the recovery system, and we have the recovery system right here. Okay.
Hi.
Hi
So-
there.
How are you doing?
Love looking at rockets.
So, my recovery system connects both to the payload and to the avionics bay. Because of some manufacturing issues and complications we ran into with our initial payload design, we did have to send it out to get re-welded. So the recovery system's currently floating, not in the rocket, but
Okay.
we did have it set up in the rocket, and it was gorgeous for a brief moment.
All right.
So I have, we're doing a single, it's a dual event, single deployment thing, dual deployment, but single. I forget the actual real words for it, but basically everything comes out technically all at once, and then we have the bag that's going to pull the main parachute out using this commercial line cutter. We have the backup for this. Currently, we are working on ESRA versions, finalizing and testing those. Until we can get those through more rigorous tests, I'm not comfortable using that in the rocket yet.
Mhm.
So we're going all COTS until that's confirmed. So we're using the L3 tender descender, and that's connected to the 15-foot shock cord, which is actually in here. And I keep everything in this tackle box. So this is the 15-foot shock cord, and that's rated for 2,000 pounds. And then this is our 30-foot shock cord that will be tucked into the lines of this bag. We've done some testing on actually pulling out the bag manually just with us, where one of us stands still and acts as the bulkhead, and the other person runs as if they're the rocket pulling it. And it comes out of the bag without tangling, even if we turned and twisted, because we've been using swivels to connect.
Yep.
And then this is the U-bolt that's connecting to both the payload and the avionics bay to hold that shock, both those shock cords in place. And then the bag actually gets connected down to the top of the payload, and it'll sit like this, connected here. So then all the rocket has to do is just pull it out. So we're feeling fairly confident in what we've done. We've done some shear pin testing to verify my calculations, see how much force we need to break it. So far, we've seen that the shear pins fail after the amount of drag that we thought would be acting on the rocket, but before the amount that we're actually going to have to make it fail.
Okay. Can you turn the camera a little bit so I can see where the booster joins to? It goes from the booster to AV. Is it an AV bay or an AV tube? I'm just trying to see where these tubes connect.
So so this is the connection here, and the avionics bay sits inside of there. We have it out right now for demonstration purposes, but the bay sits in there, and I don't know if you can see. So this is the bulkhead. I'm connected on the underside of this as it's in the nose cone.
Okay.
Yeah. So in this positioning, there's the hole for my U-bolt, and then there's the hole for the carbon dioxide canisters for we're using currently the Raptor carbon dioxide ejection system, and I have that. Oh, it's right in here. And I have it in here with the canister, and then I have the backups in here as well.
Okay, so just trying to visualize this, usually we'll see a booster, and then we'll see like an AV bay, and then we'll see the payload bay. What we have is one really long piece that is your booster and your payload and everything, and we're pushing everything out the head end on this. So
yes,
okay,
correct.
All right, and so that's what you mean by you have a single event, but dual deploy. Yeah.
Yes, because we're not separating like the typical. It's not main here, drogue here. It's main, drogue main, like on the same section of shock cord.
Okay. All right. And I heard 20 feet and 15 feet, that there's two different cords. So help me understand that, like that, like there's the 15-foot one, is that going from attaching to the payload and then through the tube.
So-
I hard time visualizing it. Yeah.
So they both attach at the same exact points. They both attach under the avionics bay to the payload. The first one, the 15-foot long shock cord, that will be technically the primary shock cord. When we eject the drogue at apogee, that is the shock cord that will be coming like fully out of the rocket and maintaining that length.
Okay.
Once we reach 1500 above ground level, that's when the line cutter will, the tender descender will separate that end of the 15-foot, removing it, causing the 30-foot shock cord to get pulled from the bag. Now the main shock cord length is 30 feet, and that 15-foot shock cord is useless.
Okay. All right. Okay. All right. It was just a little hard to visualize, but that's fine. Yeah. No, that's fine. So, tell me a little bit about like the testing that you've done. I mean, you've done some ground testing maybe to just make sure that it's pushing out all the laundry.
Yes. So we did an ejection test to make sure that the drogue is actually going to come out when the carbon dioxide does work. We did a Instrom test to check that the actual amount of weight is going to work for the shear pins. And then we're working on a test for hanging the rocket and then pulling a weight on it to see if it's going to pull the bag out of the main. That test is a little bit harder to kind of figure out how to do it. We've been able to do it manually, but I'm not really sure how to do it without actually launching the rocket to fully see if that bag is going to come out.
Sure. Well, that's yeah, because you basically need the wind blowing past the rocket to pull it out, right?
Yeah, and we do have a little smaller scale rocket that we've been trying to launch, but Ohio weather hates us. And that's going to try to pull the bag out to see if it just works on a smaller scale at least.
Okay. Well, here in Iowa, we felt like that the weather hated us too. I mean, that we had many launch opportunities canceled because of weather. So I get it.
Same here.
Yeah. Okay. You have a deployment bag. Is your drogue just maybe covered in fabric or something like that? Or
so the drogue is actually not covered at all because we don't have any pyrotechnics happening.
Of the CO2. Yeah. Okay. Yep. Okay.
Yeah. So we have no fear of our drogue catching on fire, and if it does, then we should go apply for the lottery.
Yeah. But you have assurance that the drogue is going to get out. It's not going to get tangled or confounded with everything else.
No, I'm really concerned about that with the two shock cords. We found that if we put the drogue on the shorter shock cord, it would tangle with the main shock cord line. But when both the main and the drogue are on the same shock cord, the lines don't tangle because there's not as much trying to wrap around.
Okay.
So we did end up having issues with that initially, but we were able to solve the tangling issue, which is always so fun to deal with.
Yeah, right, with the swivel. Well, the choice of Kevlar for your cords, I mean, obviously that's like super strong. I don't know if you need anything to prevent the cord from rubbing against the edge of the rocket body tube as it's coming down, or any, I don't. Is that something you've considered, or but you don't need it?
So you're saying it rubbing against the internals, like?
Well, no, like someone just pointed at it. Where the rocket separates, as it's coming down. As you're descending from altitude, that cord is going to be brushing against the edge of the tube. That would be an opportunity for it to fray. Now, it would be remarkable if you could cut through a Kevlar line. I mean, unless maybe you're descending from the edge of space or something like that. But some people will, they'll use a tennis ball or a disc, or they'll have something there that's preventing the cord from rubbing against the edge. And I'm just asking if you considered that or dismissed that, or
Oh, I've actually not considered that, but that is some great food for thought. I'm wondering almost if you were to sand the internal edge and then maybe put a smooth layer of epoxy over it, if that would kind of help prevent the fraying because it's not hitting a rough edge anymore.
Sure. Yeah, I don't know, but and then I'd also say that a tennis ball or a disc also there's also while it'll prevent it from rubbing, it is also something else to confound, right? It's something else that can get
Yes.
stuck or ruin your opportunity. So okay, so you have a subscale of this but you've been unable to test it.
Correct. We're hoping that we get to test it. We were hoping for this weekend actually, but it's supposed to pour down rain here on Sunday, so it's looking like launch is going to get canceled. So we're looking to do the next launch at the Pittsburgh Space Command, the Pittsburgh Space Command launch site, just to make sure that our internals work as we hoped. Obviously, won't be characteristic for the behavior because we're not going Mach speed during our little flight.
Yep.
But
okay. Very good. Well, I'm okay with this. It's a little different. If I was your advisor, I tend to like rockets to separate in the middle, just because you're disrupting the aerodynamics that made it go up so well. Everything that's an asset on the way up is a liability on the way down. So kind of like that. But this is that's part of this contest is trying new things and doing different and engineering things like that. So thank you. I'm satisfied with the recovery. And she's like, good, get me out of here. Yeah. So and it looks like we're going to talk about avionics now, electronics.
yes, here's the segue.
Yeah.
So as she said, okay. Our avionics bay this year is stored within the nose cone. Due to that, that is due to just us not having that much room. This is also our first time doing a minimum diameter rocket. So we figured utilize the nose cone as none of our teams really have done before. So this is actually our avionics bay assembled. I know the wires are a little bit messy. This is not the final product.
Yep.
But we have two altimeters, one main and one backup this year. And then also two GPS, one main and one backup again. This year we have 4 batteries. Last year's team had a problem with battery life. So we upped the milliamp hours on our batteries, and we've actually already tested them. And they will last well over 24 hours, which we were very happy about. But going into the actual design of it, the profile of the sled, it's hard to see, I'm wearing a black shirt, actually matches the profile of the inner of the nose.
Yep, I can see that.
And then it is 2 sleds. I don't know if the slot through the middle, and all thread will be fed through there. And that will actually connect it to the nose cone. I could pull it out here. It'll be a little bit easier to show you.
Yep.
This all thread within the middle will sink all the way down through to ensure that the avionics bay will not fall out when the parachute is attached to it. And that's obviously just the metal tip from the top that it is connecting to.
Yep.
It fits very well. It's very snug. It doesn't wiggle at all. Actually, when we first manufactured this in-house, it was a little too big, which was honestly good. We sanded it down so it was a better press fit. It is now a press fit on the edges here. And then the bulkhead actually is the same diameter as our coupler. So it sinks up right in, so it fits snug there as well, making a good 3 points of contact, as well as the all thread through the middle. It expands it, it pushes it out, so that is also pushing on the outer of the nose cone.
Mm-hmm.
So we've done some tests with the GPS system as well. I actually turned it on when we were doing battery life, and I tracked myself driving all around town that day, actually. So it was pretty cool to see on the new Featherweight app. It's first time using that.
By chance, did you stuff all that stuff in the nose cone when you were doing those tests?
We did not do it that time, but we have done it since. We've stuffed it in there, and we still get good telemetry. We still got good readings. It was still very accurate.
Right.
I actually live in the middle of nowhere, so I actually tested it. I had my dad walk outside and test it and see if I could find them, and it still worked then as well.
Okay. Yeah, I was about to ask a really dumb question, but obviously the nose cone is fiberglass, and that's why you're able to have your GPS up there.
Yep.
So yeah. Okay.
Also,
All right.
we insured because of the coupler. Some of it sits down low, so the batteries sit down in the lower part, which is will be interfering with the carbon fiber tube. So we ensured that the GPS systems were up high enough so they are within the nose cone too. We did make sure to ensure that it wasn't going to interfere with the carbon fiber.
Okay. So obviously, the risk of putting everything up in the nose cone is if it were to separate from your rocket, you'll find the nose cone, but finding the whole rest of it. So that's something I could see coming up as a discussion in Texas. Is to be able to assure people that it'll stay together so that you can find it, and it would also be really scary to send that big long tube on its own towards the Earth without So,
Gotcha.
Yep.
I think of some tests here to ensure that it will separate as well.
Okay. Thank you for you didn't mean to, but just by setting it there, looking at your wires, I know you said it was you're just working on it now, so you'll have it neat. Being somebody who's had to review rockets, when I see wiring that's nice and neat, that automatically drops my suspicion orders of magnitude, right? If you can do it neat, then it makes sense. What I'm seeing in the picture right here, and maybe that's because these wires are for testing, but you've exposed way too much wire on it. That can you see all the
yeah. Yep. And that was one just so we could ensure the testing.
Sure.
We've actually had trouble getting in the wires. I've ordered them multiple times, and they just have Amazon keeps denying my orders. So this is just all pretty much test wiring to ensure
okay,
that
and that's totally fine. Just make sure that you don't expose too much wire. So what we like to see no shiny stuff. Okay, we like to be able to only see insulation at those terminals. That is definitely something someone when you go through that they'll take a look at that. So I think you maybe alluded to it. Have you done a drain test? How long can this operate?
Yeah, so actually the shortest battery life that we run into is actually our ground station. And that was a battery life of just around 16 hours.
Okay.
And the battery life of the actual components lasted an additional 8 hours. We stopped it at 24 hours. We felt the need that once it hit 24 hours, it was we ensured ourselves that it was going to last. Now what we could do, now that it's getting a little bit nicer here, we could do it within the heat. That's a big concern for us, is how the heat is going to affect the batteries. So we do have spare batteries here as well that we could just put in the nose cone. As of right now, it is still black. We have to paint pretty much the whole rocket white still. So once we have it painted, that would probably be a better test to further get a closer test.
Sure.
Obviously, Ohio doesn't get Texas heat, but it's better than nothing to test it in the heat.
Yep. So, that'll be good. I mean, normally we're recovering rockets the same day. Once in a while, they spend a night in the desert and get picked up the next day. But I'm sure that a lot of this, even if your batteries did go dead, the last location and stuff like that. So you're still able to get them. So okay, very good. Don't see everything up in the head of the rocket a lot. Definitely see a lot of tracking and things up in the nose cone. Never seen altimeter. So you drilling holes in your nose cone?
Correct. That we are actually waiting to do once it is finalized 100%. just because
Okay.
we don't want to drill too many extra hills within the nose cone.
Yep.
But we will be drilling holes within the nose cone as well.
Okay. All right. I think that I see Missile Works there. They have really good instructions telling you for the diameter of your rocket, how many holes and the diameter you want of those holes. So yeah.
Yep. And I
Yeah.
have that in my notebook as well.
Okay. All right. It'll actually impress people you talk to if they, you mentioned that you read the instructions, because that's a big bonus. So
Oh,
all right. Yeah. Hey, since I don't know what you guys want to show me next, but the way you set the camera, I was able to see the wind for your body, and I'm very interested in, we do the same thing here where we have an X winder, but we don't have a modified one like yours that can make such long tubes. Yeah, tell me about winding that body.
I will. I will show you it. I will share with you my screen, actually, as soon as I open up my Word doc. Sir, I am going to show you the mandrel press that we made.
Yeah, that was we shared that idea. That's from here at Iowa State.
That is true. That is right.
Yep.
You remember Eric Hake?
Yep.
Well, we did what you guys did, but bigger.
Yeah. It did look bigger, longer, and maybe more robust. We do have trouble with the threaded rod bowing, but there are some ways that you could put travelers on that'll keep it from moving around. But dang, look at that.
Do you see my screen, sir?
Yeah. That is a beefy threaded. Good Lord, look at that. Yeah.
Yeah, we have a 1-inch steel rod.
Yep.
And a disc for pressing off the spacers that we use to get it to a specified diameter.
Yep.
That's what we did. We do have some concerns with how we did it. We could probably make it better for next year.
Yeah, awesome. Yeah. But
yeah,
you have tried it. I mean, you've pushed a tube off of it and it's worked for you.
That's what you see right here.
Okay. All right. That is, yeah. Okay. I probably not your actual rocket, right? Or because didn't you already have that one out?
No.
Oh, okay. All right. Well, cool.
No,
This is
the actual rocket, or this is the actual body tube that we got off.
Okay. And so you didn't have any bowing on the rod?
So the bowing came a little bit, yeah. But what we did to minimize that was we printed some of these and put them inside the actual body tube.
Yep, perfect. Yeah, I didn't know what to call those, and I said, guys, we need something that travels through there. So we called them travelers or whatever. But no, that's really cool. One of the things that we're gonna do when you bring it is we're gonna just grab that whole tube and give it a good squeeze. I mean, how thick are you? Okay, I believe you. We've seen a few soft ones. Well, actually, we've made some really soft tubes. Just trouble with the X winder, but you know that it takes a while to dial those in. So
yeah, we actually stood not on this one, but we stood on one of the ones that we had test wound before.
Okay, all right. So you don't stand behind your tubes, you stand on them. So yeah. Exactly. So okay. All right. Okay. Well,
we actually have done material testing as well. Do you want to hear about that?
Sure. Yeah, absolutely.
Okay. Hi, back. So we did 3 forms of testing for rearing material composition of our body tube. The first one was a traditional dog bone tensile test. We there's an ASTM standard, D3039, that goes over generalized testing for fiber reinforced composites. It just tells you how to make the dog bones and basically says that you're allowed to treat this as an elastic material like steel or other metals. so you can just go through and analyze accordingly. We also did a hoop compression test, kind of like standing on a hoop specimen, but instead of using the Angstrom. We didn't really use it for data, but we just did it to see at what loads does failure occur. The last form of material testing we did, and it kind of goes back into that we only have one, excuse me for a moment, only one connection to the airframe being the motor bulkhead. We did a tear-out test to figure out what loading causes failure of the fibers or failure of the 4 pins. Because during our design, we weren't sure if we could get away with 4 screw holes. Did we have to go 6, 8, 12, however many? With the 4 screw holes, we actually get a factor of safety of around 2.5 regarding loading. Our critical loading that we've been doing for our analysis has been peak thrust plus max drag, which is around 2,100 newtons. For the fibers to start really failing, it's around 18,000 newtons. So we are safe in that regard. So yes, we have done a lot of testing on our winding procedure, not just standing on the tube, but that's pretty fun.
Yeah.
So
yeah. I would stand on it too. So that's just the way it is. So you held up that bulkhead, and I get it that you're going to put 4 screws through that. I'm assuming those 4 screws are probably like stainless or something.
Yes.
Like, yeah. Okay.
Stainless steel, 1/4-20.
Okay. All right. You don't have to do this. This is just a suggestion that a lot of those screws have a Phillips head for turning them in. I feel that the hex head that you can put a Allen key in and turn, they're just easier to grip, and you're able to make them just a little bit tighter. Yeah. Okay.
Yeah, we got
All right.
those. We're good.
Okay. All right. Because otherwise, you know what I'm saying. You're out there and you're turning, and your tool is hopping out of the grooves and stuff like that. So, yep. So, if you said you were using Phillips, I wouldn't say no, you can't. I think that the hex are better and a lot less stress in the field and so on.
Yes.
So, okay. Let's see. We looked at the fin attachment. We looked at where your motor's going in. We've looked at your recovery. We've looked at the avionics, and we even just looked about the actual physical tube that you made. That is really a nice looking wind, I will tell you that. It's so hard. It's so hard to get those machines dialed in. What are we missing? What else do we have to go through on this?
I don't think anything else, but I do have some other photos to show you.
Okay.
This is what our inner mandrel looks like, or sorry, our inner tubes look like when they're being pressed.
Okay.
We're currently trying to press one out ourselves.
This is actually the stage of the test rocket we're trying to launch at the end of the month.
Okay.
Yep.
That is so cool.
And yeah, that's what we got right now.
Okay. And then are you just turning that center screw with an impact wrench or something like that?
No, the impact wrench actually makes it jump too much. We recommend a ratchet.
Okay. All right. I think when I was talking to you guys, I mentioned the impact because it provides vibration. But I've learned from the students, one, they don't like the noise, and and two, that it was moving around. So they too, like you, have gone to a ratchet. But I think they might be using a cheater on it to
the cheater. Oh, I get a bar.
Yeah.
We're doing that too.
Yep.
Okay. So since we have some time, let's talk a little bit about that motor that you're going to assemble. Have any of you done an 05500?
Nope.
Okay.
No, we have not.
All right. I've only done one. I did one and I watched one. And the first one that I did was not a pleasant experience. And so the one bit of advice I was going to give you on that, because I think they recommend the Glue All Max the Elmer's Glue All Max, I think, is the glue that they recommend or specify for bonding that motor. Make sure that you have a fresh bottle. And just because it's fresh doesn't mean, I mean, if it's been sitting on the shelf long enough at the store, the glue will be more viscous. You want a fresh bottle that is almost inviscid, because what we found, we had a bottle that it was a brand new bottle, never opened, but the glue was a little thicker than we were used to, and it put the brakes on. And about halfway through assembling it, we started to stress that whether we were actually going to get those grains in, because you have to kind of front load all of them, and it got stressful. We did finally get it in, but it was dicey there for a while. How are you? First of all, where are you assembling your motor? Are you going to do that in Ohio? Or are you going to do that in Texas?
We are going to assemble it here in Ohio.
Okay, all right, and then because that's a pretty long motor, how are you going to transport that? Yeah.
So we have a trailer rented out, a physical trailer, probably about 24 feet long.
Okay.
And what we do is we actually pack that full of stuff to make sure that the motor will be transported very safely.
Okay.
Very safe.
Is the motor, I mean, are you building a box or a shipping container, or okay, all right. That's I just wanted to, make sure that you have a nice case for it, or shipping container, and so okay, and that should be fine. It's a beautiful motor. It's pretty spicy. You're gonna fly off of the rail with that. So
yeah, I don't know our off the rail velocity by memory, but it is pretty fast.
Yep. So how are you attaching your? Well, I guess that was presumptuous. Are you even using rail buttons?
We are using rail buttons.
Okay.
Custom ones. Yeah. Let me share with you my attachment method that I have currently.
Okay.
Currently is in like right now.
Yep.
So basically how it works is we put a adhesive ready nut right there. There's the camera. You're over there a second. We put an adhesive ready nut right here, epoxied over it, and then had our layup over that.
Oh, okay. So I can see hardware, but it's not just glued on. It's the fabric is over the hardware.
Yes, sir. And there'll be a nut that obviously screws into this.
Yep.
And the rail button. This is the rail button itself. I CNC'd this, and it's we use the wedge design to minimize drag.
Okay. And what you don't have to do this, but when they're doing the safety tests, they usually have a piece of rail laying around. If you want to slide, if you've never had yours on a rail before, you can slide it on a piece of rail there and make sure that it isn't binding.
Yeah, this one slides on the rail.
Okay.
I also seen the little holes that you see right here, the divots, I guess.
Yep. Okay. And dumb question, but I have to ask it. You're using 2?
Yes, sir.
Okay. Well, I in recent years, I'm seeing 3 rail buttons, which is novel, but it's really hard to get them perfectly aligned.
Inch for the afton.
Okay, inch from the afton.
Yeah, we have one that's 2 inches from the afton. You see that? You saw that one right here and right now. Obviously. Yep. And then the second one's going to go right here, but I'm waiting to do anything before we do that.
I'm sorry, you're waiting what?
I'm waiting to do that because of the motor.
To the payload.
Yeah.
Okay.
all that.
It's going to be attached the same way. I mean, you're gonna lay fabric over it, or you just.
No, that one will probably just be epoxied in, but we can lay fabric over it.
Well, is that one up high enough that that there's room behind it, or is because obviously being minimum diameter, you're really concerned with the lower one. You know, you can't put your screw. You can only go that little bit, but that one that's upper like that, can you go through the tube or not?
Go through the motor. No, we would go through the motor.
Okay, yeah, well, yeah. Okay, so, all right. Well, that'll be something that the final review they're gonna want some assurance that they're gonna stay on, right? So
Yeah.
so you go. Yep. So okay. Trying to think, is there any? Let me just look at my steered. I think that's good. Do you have obviously your flyer record hasn't shown up? Will
Yeah, I don't know what's up with that.
Yeah, we'll I'll ask the ESRA folks what we do. You know, if worst case scenario, I guess maybe I do a Zoom meeting or give them a call or send them an email and say I went through it and make sure that I should have it. I think it's in your application each time that you're. Yep. So just need to know that he has been involved. As you've been going. I don't know if he was invited to your critical design review or anything like that.
He was, and we told him about this meeting specifically.
Okay.
But he's at work.
Okay.
He's working right now for Goodyear, and he's in Texas at the racetrack right now. So he told us that he'd be here if he could get off the track, but obviously he's probably racing something right now.
That sounds cool.
Yeah.
Yeah. Do you guys have any other questions for me?
I don't have any other questions, and everybody else is shaking their head no.
Yeah, I can't remember. How many years have you been at IREC? Is this?
We have been at IREC for 3 years now. 2022, 23, 24, 25 will be our fourth.
Okay. The only thing is, this year, because it's in a different venue, none of us know what's going on, right? I mean, none of us are familiar with the road going in and things like that. One of the things I noticed they changed in the rules, I'm actually thankful of it. You know how you used to get like some bonus points if you were on the rail first day? They've taken that out, which I hope maybe incentivizes not racing through the desert to get to the launch site in the morning. These roads are rough, and if you fly through those roads on the way in, there's a very good chance that you're going to separate that rented trailer of yours from your vehicle. It's
slow.
You're gonna have to take it easy. But the fact that you've been there before, you understand that just staying alive in the sun is half of the competition. Right. So,
Cal and Julia have all been there last year.
Okay. All right. So, we always have medical people there if people need it, but regrettably every year someone does need it because they dry out on us. So, okay.
Yeah.
Well, again, save your recording, share that with the good people at ESRA. And if anything comes up between now and June, just email, call, do whatever you got to do. So, good luck. I'm looking forward to seeing it. This will be a good time. That's
Thank you, Bill. I got one last question.
Sure.
Who do I send this to? Is it just like?
I knew you'd ask me. It's in the instructions of how you submit that, but I don't think you actually send a file. I think you send a link to where you're storing it. Yeah.
Yep.
So that they can go through it. So, all right.
Okay.
I can look after we get off of here and look. I can read the same stuff you're going to read, but you know, we'll get from there. So good luck. I look forward to seeing this. It's going to be a really fast rocket.
Thank you, Bill.
Yep.
We're
all right.
trying to be.
Yep. All right. See you guys later. Bye-bye.
Good luck.
Bye, Bill.